Yes, good morning, everyone. Thank you. Welcome to Mr. Samwealth's MTH classroom. Today I'm going to be starting the new topic with us, which is vectors. Vectors. We're going to be meeting vectors in our physics, in our mathematics. If particularly if you're a science student, you'll be meeting it more. So shortly, without wasting our time, I would just like to introduce what we call vectors to us. Then after this, in the next video, we'll start calculation and all those things that is needed in vectors. Now, what do we call a vector? Definition of a vector. Vectors are objects that has both magnitude and direction. I believe you can see that. Vectors are objects that has both magnitude and direction. Now, example of that is displacement. A displacement has magnitude and direction. Velocity, forces, acceleration. Acceleration has magnitude and direction. Now, what do we call magnitude itself? Magnitude is the size of object. It is either how big or how long or how small the object is. Magnitude are usually represented with unit like centimeter, meter, second, and lot of that. I believe you understand. We can represent our magnitude by centimeter. We can represent it by meter. We can represent our magnitude by second. All these are magnitude. Magnitude simply means size. That is how big or how small an object is. That is what we call magnitude. I believe you understand this right. Thank you. Now, I said vector is a type of physical quantity, because I will be explaining physical quantity. It's a type of physical quantity that we know both the magnitude and the direction. That is, in a vector quantity, both the magnitude and direction must be known, must be given. Once it is given, such quantity or such object is a vector. Now, let's talk about physical quantities. Physical quantities can be classified into two main classes. And the classes we're talking about, they are the scalar quantities and the vector quantities. The scalar quantities and the vector quantities. Please pay attention. Now, if you are told to differentiate between these two now, scalar quantity has only magnitude. It has only magnitude. Scalar quantity has only magnitude, but no direction. It has only magnitude, but no direction. That's a scalar quantity for you. Scalar quantity has only magnitude, but no direction. That's scalar quantity. Why vector quantity has magnitude, both magnitude and direction. I getting it? Vector quantity has both magnitude and direction. You know your direction. Now your direction is usually in north, south, east, west. That is your direction. For example, a boy that is walking 60 kilometers towards the east, walking 60 kilometers towards the east, or jogging 60 kilometers toward the east is an example of a vector. I getting it? Because it has magnitude kilometer and direction east. You get it right? So that is what we call vector quantity. So always pay attention to it. Vector quantity usually have both magnitude and direction. Now, the next one we have to understand is that the example of scalar quantities, because I've not mentioned it here, at least here I've given us example of vector quantity. Example of vector quantity as forces, velocity, acceleration, and lot of that. But in scalar quantity, the examples are the time, mass, volume, length, area, and lot of that. So I'm very sure that some of us don't know the difference between mass and weight. Mass is different from weight. Now, when you are weighing a turkey of 2 kg, once you put the turkey on the scale, I'm trying to tell the difference between mass and weight. Mass is different from weight. I'm talking about mass and weight. Mass is different from weight. Now let me explain what weight means so that you know that mass is a scalar quantity and weight is not a scalar quantity. Now weight is a vector, that's what I mean. Now when you are weighing a turkey of 2 kg, now you place it on the scale. Let's assume this is my scale, this is the turkey, this is the turkey, this is the turkey, this is the turkey, this is the scale. Now you are weighing a turkey and you place it on the scale. Immediately you place it on this scale, what happens to this scale? It goes down. It's moved down. This is the load and it goes down. Going down means it shows direction. Definitely it is having magnitude and direction. We can now say weight is also an example of a vector. I believe you get it right. So I would like you to try to go through the video very well and understand an importance in there. Everything mentioned in this video, they are very, very important to begin the learning of vector. If you don't understand it well, it may be a problem in learning difficult parts in vector or mathematical parts in vector. Vector has both magnitude and direction. Scalar quantity has only magnitude. All right, thank you. So I would like us to practice this question. You have to fill the gap with either scalar or vector. The number 1 is northeasterly wind of 20 knots is dash quantity. The weight of a 8.2 kg mass is a dash quantity. An acceleration of 10 meter per second square vertically downward is a dash quantity. A temperature of 37 degrees Celsius is a dash quantity. The sum of 1.2 billion naira is a dash quantity. Try to drop your answer in the comment section and let's see if you understand what we call vector and scalar quantity. Thank you.